Hi, I'm Pallav from Just Tutors, and today we will learn about sound and its properties. So these are the points we are going to discuss. First is sound waves are longitudinal. We have different types of waves like longitudinal waves, transverse wave. So sound is a longitudinal wave. We will learn about it. Then some characteristics of sound like frequency, wavelength, time period, and then speed of sound in different mediums. So the sound speed is different in different mediums. We will learn about it. And then the last one is reflection of sound. We have studied a lot about reflection of light. Today we will learn about reflection of sound. So let's move on. Before we move further, I want you to try these questions. So you can pause the video, try these questions, then we'll move on. Well, these are the answers of given questions. I hope you got the correct answers. Let's move on. So first point is sound waves are longitudinal waves. We have different types of waves like longitudinal waves or transverse wave. In case of sound, sound is a longitudinal wave. Now, what is longitudinal wave? Actually, we know that wave is a disturbance when anything vibrates. In case of sound, when anything vibrates, the particles of the medium start oscillating. So, in case of longitudinal wave, the particle of medium moves in parallel direction of propagation of disturbance. Particles may simply oscillate back and forth. In case of transverse, the particles oscillate up and down, but in case of sound waves and longitudinal waves, particles move back and forth about their mean position. So sound is a type of longitudinal wave. Now we will discuss about some characteristics of sound wave. Any kind of wave have these types of any kind of wave has these types of characteristics like wavelength, frequency, time period. So let's discuss that. So if we talk about wavelength, wavelength is a distance between two continuous crests and troughs. And as it is a length, so its unit is meter, its SI unit is meter. Now if we talk about sound, we know that when the object vibrates and in vibration when the object moves forward, the particles get compressed and the region of high pressure is created like this. And when the object moves backward, the region of low pressure is created like this. So this is called compression and this is called rarefaction. And then again we have compression then rarefaction. So this cycle continues. So the distance between two compressions or two rarefactions is called wavelength of the wave. And if we talk about frequency, frequency is the number of cycles per unit time. And the unit of frequency is hertz. So in 1 unit time, how many times the cycle repeats is called frequency. And then we have time period. So time period is the amount of time taken by two consecutive compressions or rarefactions. And it's opposite of frequency, so its unit is seconds. As it is a time period, its unit seconds. Now let's move on. We have some more characteristics like pitch, amplitude, loudness, and quality. So pitch is about like how high the frequency is of any sound. So if higher the frequency, higher the pitch. Lower the frequency, lower the pitch. And amplitude is so the amplitude is a magnitude of maximum disturbance in the medium on either side of main position. Means if we talk about this, like this is the mean position of the wave, so how much distance, how much difference we have from the mean position is called amplitude. In case of sound, it is measured in density or pressure, because we know that when the sound is produced by vibration, and when the object vibrates, the particles get compressed or create the low pressure. So we measure the amplitude in case of sound in density or pressure. Now loudness. It depends on the amplitude of sound wave. Higher the amplitude, louder would be the sound. Then quality. If two sounds are there with the same pitch and the same amplitude, the sound which is more pleasant to listen would be of more quality. Then speed of sound in different medium is different. Sound in solid is more than sound in liquid, and the sound in liquid is more than sound in gas. And sound also depends on the temperature. So in particular medium, let's say air, the sound at the higher temperature, the speed of the sound at higher temperature would be more than the speed of sound at lower temperature. For example, we have speed of sound in air is 331 meter per second at 0 degrees Celsius, but at 22 degrees Celsius we have 344 meter per second. Now reflection of sound, we have learned reflection of light. In the same way, reflection of sound is same, like the law of reflection of sound is same as law of reflection of light. Angle of incidence is same as angle of reflection, and the incident wave, reflected wave, and the normal all lies in the same plane. We can understand by this. Let's say we have two tubes, one is for the source of sound and the other one for the receiver, and then we have another normal here. So we can listen to the sound at the same angle with the normal at which it is produced. Well, sound is reflected well from the hard surfaces, and sound waves get absorbed by the smooth or soft surfaces. So we can understand it by echo, like if we are in the empty room, like there is nothing in the room, just walls, then we can listen to more echo. But if we have a room full of cloths, then our sound will get absorbed there. Then applications of reflection of sound, it's one important application is stethoscope, like doctors listen to it. So sound reflects a lot in the tubes of a stethoscope from the inner walls. And sometimes curved soundboards are used behind the speakers to get more sound. And now the practice questions. So you can pause the video, try these questions, then we'll move on. These are the answers of given questions. I hope you got the correct answers. Thanks for watching this video. For more, you can visit justtutors.com. Thank you.